Hello, I'm Peter Fiddleman, and behind the camera is Dustin Waldy, and this is our final project for EE205, a AM radio. So, we've got, of course, our split power supply. Over here is the tank. We've got a resonator and a variable capacitor, as shown in the write-up, and we got a rectifier. Then followed by the RC filter. This is unchanged from the one in the write-up. But then our filtering is an active filter. We use a two-stage 4-pole Butterworth with a cutoff of about 160 hertz. This basically blocks the low frequencies, blocks the annoying 60 hertz hum pretty well. From that filtering stage, we go to the first amplification stage, a non-inverting op-amp circuit with a gain of about 1000, and that drives the headphone out. Cascaded from that is another filter, or rather another amplifying stage, this with gain of about 400. This goes over here and is itself rectified by a diode to drive the Arduino's analog input. This allows us to figure out the signal strength as a DC voltage greater than 0 and use that in our tuning algorithm, which we'll get to later. Anyway, aside from driving the Arduino, this also goes through a voltage divider, and there's goes back over here to this switch. Now, this gives the option to drive the headphone output off of a scaled down version of this amplified signal. Like, it ends up having a gain of about 3 times just the first stage amplifier, which is selected right now. So this would function as a volume control, but it's not really working as designed. Instead of actually boosting the volume, I mean, it does do that, but then the volume gradually decays to nothing over a period of about 10 seconds. And we've looked into some things that could be causing this, but we never actually tracked it down because we've had other priorities in this lab. That's a suggestion for future improvement. But also, this switch powers the Arduino off 9 volts, or when you turn it off, it's unpowered, so you can use USB. Anyway, so as for our tuning algorithm, we use this bank of capacitors over here. These are 220 picofarad capacitors in series with wires here going to the Arduino's digital pins. This allows us to ground at various places along this series, and therefore, like, half the capacitance from 220 to 110 to 55 and so on, all the way down to about 2. So this corresponds pretty well with the capacitances we need to programmatically tune along the AM band. So basically how our tuning algorithm works is it checks the signal strength of the voltage coming into this analog input, and if it falls below a certain threshold, it engages seek mode. What this does is steps through ground, moves the ground point along this line of capacitors, and checks to see which resonant frequency, like which tuned frequency, produces the best output. And then once it's seeked, it returns the loudest frequency, and we'll just hold on that frequency until the power level sensed goes down to 1/100th of the max that seek saw. So that basically allows it to retune if the signal strength goes below a certain threshold, and automatically reacquire the strongest signal in the range.
I mean, that's if we want to be like...
Anyway, this about sums up the hardware of this project. Thanks for watching, and goodbye.